Okay, time for another challenge in the 7 Caillou series. This one's called Minimize Sum of Array. They have an introduction warm-up that I'll skip. You are given an array of integers. Find the minimum sum which is obtained from summing each two integers product. And that's not worded very well, but you will see that they mean that you can imagine that each element could be paired up in any combination. The 5 could be paired with the 3, for example, or with the 4, or with the 2. Any sort of all the possible ways of combining the array elements into pairs, and with the idea that each pair gets multiplied together and then you sum all these products. How do you get the lowest overall sum is sort of what they mean here. It was worded not so well and it took me a minute to figure that out, but that is what is going on here. They note that the array will contain positives only, and the list always has an even size. That's important, right? Because we're saying that each element has to have a pair with it. If you had an odd number of elements, there'd be an odd man out. So again, we're not going to necessarily rely on that. You can enforce these. You don't have to just believe, but just believing's bad in this game. Explanation, yeah, we kind of went over that. In this case, 22 is the lowest. Feel free to combine the numbers in different ways and convince yourself that 22 is in fact the lowest for this simple example. And then they have a more complex one. Hopefully it's clear from looking at the first one, but if you want to write out all the combinations here and convince yourself, there are more clever ways to attack the problem. Will be your hint, as opposed to going through and doing all the permutations. You could do that though, right? You could do a brute force kind of thing and just go through every possible combination and see which sum comes out to be the lowest. Not the most efficient, but you could do it. And then anything else useful here? Not really. Kind of saying the same thing over again in a not so clear way. But that's what's going on, so you know what to do. You know it's time to pause the video and try this one out. And then come on back. So, time to do some magic, as they say. Now, I hinted that there might be a better way to do this than the brute force, just trying to combine numbers in crazy ways, every way, and then keep track of all these sums and find the lowest one. So, the way I like to think about this problem is that think of it like whatever the maximum value in the array is, in this case 5, you want it to occur the least number of times. So you notice 5 was paired with 2, right? It's the heaviest element, and if we have to multiply the biggest element, you know, it seems to be reasonable to multiply it against the lowest available option. And it worked out here, right? 5 times 2, the next bigger element is 4. It gets paired with the next least element, which would be 3, and it works out to 22. So looking at the other one, you're going through this list here, you find, ooh, 26, big boy, right? You don't want to multiply that by 12, do you? Or 24, you know, grab that 3. Okay. So with that in mind, maybe that gives you some ideas. The way I wanted to look at it was knowing that, what would be a convenient form for the array to be in to achieve that? And so step 1, I think of sort the array, right? If I sort it in descending order, then it'll be very easy for me at any point to determine what the maximum element is and what the lowest element is, right? And then sort of once I have it sorted, what I'm going to do is I'm going to make pairs, right? Make pairs by combining elements from the front and the back. And then, you know, front and back are going to continually move inward towards each other until they meet in the middle, right? And I suppose really step 0 enforce valid input, something like that, right? And then once you have all your pairs, once you're sorted, I guess this number 2 is going to happen while we're processing the sorted array, right? So you'll make the pairs, you'll multiply them. You see, that's the rules for this, right? They multiply the pairs and they add each product, each pair product. So we'll take care of that in the for loop. So let's get on to step 0 there. What did they say? They said it's got to be an even number of elements in the array. So very important. Let's do a quick check. If a.length, we know arrays have a length property. And then do you remember how to check if something's an even number? That should be hopefully getting ingrained into you now. And we know that we can say modulo 2, right, is not equal to 0. If you divide the number by 2, there shouldn't be a remainder. If there is a remainder of 1, then you're dealing with an odd length. Remember, the modulo here is either going to be 0 or 1. In this case, let's just throw an exception. Throw a new argument exception and say input array must have even number of elements. Whatever you want, it doesn't matter. Something that's helpful for you, so when this exception gets thrown, you're gonna know how to handle it. Okay, so once we have that, the next part is sort, right? Well, how do you sort? As you can imagine, it's an extremely common operation in C#, and your spidey sense should be going off that someone probably already solved this problem. And they did. You can go through the docs and find the array.sort method. And so let's go down and check it out. Remember, check your namespace. System will have to bring in the system namespace if we don't have it. And then you can see all the various overloads of this. I don't need to do anything fancy with comparing, so feel free to read through these if you want a more complete understanding of what's going on. We're going to keep it simple here, and we're just going to pass an array in. So as usual, I like to say go right to the examples to get a quick idea. I'm not telling you not to read. Reading's good too. But notice you call array.sort the class, and then you pass in the array that you want sorted. So this is an overload, but don't worry about that. We're just all we need to pass in is the array itself, and the default behavior should be to order in descending order, like you see down here. So let's try that. Array sort, and our array here is A. And we know we are going to get in trouble if we don't bring in the system namespace, because we didn't define any of this array class, right? So, okay, good. So once you call this, A will be in sorted order. So now we've got to go through the elements in the array, and I'll set up a simple for loop for that. I is less than a.length, and if you think about it, since we're sort of grabbing elements from the front and the back at the same time, we start at the ends, then we move in one closer on each side, one closer until we meet in the middle. We don't need to go over the whole array, right? We just need to go over half of it. So a.length over 2, and then increment each time, right? Because for each pass through this loop, we're getting 2 elements. So we only have to go over half the length. And I need to set up some variables to sort of point at where we should be pulling values from. So I'll say int, let's call it front index equals 0, right? We want the first element to start. We can make a rear index and set that equal to the very last element, which should be a.length minus 1. Remember, indices are 0 based, not 1 based, so you got to go the length minus 1. If there's 8 elements, you want to access element 7 for index 7 to get the last element. And then finally, we need to keep a running sum of our products, right? And that clearly should be initialized to 0. So, good, now we can start working with this. Now what we want to do is grab our two values, right? And so how do you access the values of the array? You could say, A, and we use the square brackets to get the element. Let's say front index. And we know we multiply the two, right? And it's going to be added to the sum. So I'm going to set this up. Remember that shorthand, plus equals means sum equals sum plus whatever value we want. Just a shorthand. Should be comfortable with that by now. A rear index, right? We're going to be accumulating the products each time, right? That's what we have to do. You multiply with the pair and then you add them all up. So now obviously we have to update what these are pointing to. We don't want it to always grab the same elements each time. You don't want it to always grab, in this case, the 5 and the 3 and keep doing 5 times 3 equals 15 plus 5 times 3 equals 15 when you should have done 4 and 2 next. You'd get a result of 30. That's clearly wrong. So what you need to do is increment the front index, right? You want that one to go forward and you want the rear index to go backwards towards the middle, right? You'd go back from the 3 to the 2. So you can do that with this handy postfix notation, or you could put it right in the statement that we're working on. And it might look a little scary. If it's too scary, you could always put this part outside. Let me show you. You could just make it in separate statements, right? But when you do this a while, you're like, I didn't need to do that. I can just do it here. And as long as you use the postfix, right? Because it would be different if you put prefix. That means something different. That means, hey, decrement rear index first, which means you're going to miss the last value and you're going to grab the 2 here to start, right? And then it's going to multiply by 2. That's not what you want. So the order matters. Put it at the end if you want it to be incremented or decremented after the entire expression is run. This way it means run this whole expression first, and then behind the scenes bump front index, decrement rear index. So hopefully that's clear. It's nice. You can do it on one line. I don't think it looks, it's not confusing about what it does. So still clear. And then we're adding to sum each time, right? That's what we need to do. And then finally, you can imagine at the end here, you've added up all these products and simply return the sum. And that's what they wanted us to do. Remember, that's our contract here. They're going to give us an array. They expect an int back with the minimum value. And so by sorting, we sort of pull the largest value at each time and pair it with the smallest value to minimize the damage, if you will, of the larger elements in attempt to get the smallest sum possible. So I'll go ahead and give this a test run. Looks good. We'll hit the attempt to be sure and clear ourselves for submission. And we have green, the best color. So I think we're good here. I'm going to get rid of my comments. It's just meant to be. Show what I was doing. Okay, yeah, using system exception. I like it. And yeah, we're good. Hopefully you agree this is better than trying to pair numbers in all these crazy ways that possible. You can imagine if the array size is really big and you're doing all these pairings, and That would not be fun, would it? And so you can imagine the quality of our algorithm here relies a lot on how fast and efficient the sort method is. And how does C# array sort work under the hood? Which version of which sorting algorithm does it use under the hood? I don't know off the top of my head. You could research that. If you're having trouble, you may need to, if you had inputs that came in a certain way where you could leverage it because you knew it was in more or less some kind of ordering, maybe you could take advantage of that. But for general purpose, I think you'll find that this is fine. But if you get in trouble, it would be something to scrutinize. So good. I'll go ahead and they're going to make me attempt again because I changed the code. And you know what? Since this is just one line, we don't need the curly braces. They don't hurt. Just condense things a little bit. I usually don't put the curly braces when it's just one line. So good. We're still green. I'll go ahead and submit. I imagine there'll be a bunch of different answers here. Let's see. Yeah. There you go. Power link user here. Look at this. Order by skip. Zip it up. Order by descending. Skip. Yeah. Wally. Go Wally. More link fun. So yeah. Lots of link fun here. Feel free to look through those. Maybe some of those like zip you're not familiar with. So yeah, good stuff to ponder. You know what to do if you have questions, hit me up. Otherwise, we'll keep rolling. Thanks for watching.